I challenge you to win this game. Do you know what I also challenge you? I challenge you to build it. I challenge you to find someone who has built Snake game better than this using HTML, CSS and vanilla JavaScript. This is the Snake game which is #1 on YouTube. No one has built that before and no one will build it after him. And if that's the case, then I'm gonna challenge him or her and build a better one. The source code is in the description and I'm gonna take you with me step by step to build every single piece of logic in this game. Starting from the snake head to the expansion of the game, to the logic of eating the apples, also to the scores. As you see, the score is increasing. And if you hit the wall, you lose. But also if the snake intersects, then you lose too. The game will be built with a very clean code using vanilla JavaScript, CSS styles, very simple and clean, and a couple of lines of HTML. And with that, be sure to subscribe to the channel to get the best of the best videos out there. You will not find these videos anywhere. Exclusive on this channel. Here is your Jad, and let's get started. We got our assets, the index.html, which is empty. Then we got the script.js, the styles.css, and then the assets folder, we got our apple and the snake head, which are the assets that we are going to use, and I've already prepared these. So now let's get started to write our HTML. I'm gonna start with this exclamation mark, which will give us some markup language, and I'm gonna write the title snake game. Right now in the body, we're going to have a container. In the container, we're going to have h2 with a class score, and in the h2 we're going to write score, but also have a span with an ID score. In this span, I'm gonna give it 0 for now. We also have a div with a class gameboard and an ID of gameboard. Last but not least, we wanna link a file to the JavaScript that we got. So the source is gonna be script with JavaScript, but also are going to link it to the CSS, which is styles.css. Just for the sake of testing the CSS in the board we got, I'm gonna add two divs. First div, I'm gonna give it the class snake segment, and the other one is gonna be snake head. Let's go. Gonna save. Let's check what we got already. As you see, we got our score, and now let's style together to the styling part. As usual, I'm gonna start with a neutralizer, which is box sizing is gonna be border box. The margin is gonna be 0. The padding is gonna be 0 for all the elements. That's one. Second, I will grab the container class. Be sure that the height is 100 vh. The width is 100%. I'm gonna give it a background of black color for now, and then I'm gonna display it as flex. Align the items to the center and also justify the content to the center, meaning everything is centered. But also last but not least, I'm gonna use the fixed direction column. Let's refresh, check what we got, nice and smooth. And as you see, like the score that we got is in the middle, but it's not disappeared now because it has the same color, right? We'll get to that later. Now let's style the game board, and I'm gonna give it a height of 90 v minimum, but also the width is gonna be the same. So we got our square, not any square, it is a square which is always gonna have the square shape, right? So a responsive square shape. Let's go for the background. I'm just gonna copy the linear gradient here, right? I got some nice colors prepared already. Let's display it as grid. So we display the whole board, the game board as grid, and I'm gonna give it columns. The number of columns is gonna be 16. Fractions, the same is gonna be for the rows. Let's go. Last but not least, I'm gonna justify content or justify items to the center. Let's refresh and take a look. It looks really nice. And as you see, as we go smaller, the square stays a square, which is really nice. Let's go. Now the second thing that we wanna be sure that it's styled, it's the score. I'm gonna give it also some background color. I've prepared the color already. It's just a very light kind of green yellow. Let's take a look. As you see, but we are not done yet. I'm gonna add some padding, 10 pixels and 20 pixels horizontally and vertically. I'm gonna give some border radius of 20 pixels, which will give this roundy shape. Last but not least, we need some margin bottom, 10 pixels, so we have some space in between. Nice. You see, we've done like so much progress till now. Now let's get to design the testing elements that we've put here, which are these two things, right? Let's grab the snake segment. It's gonna be a class. The background is gonna be a green color, which I've already prepared to 219 D00. It's very green color. The border is gonna be 2 pixels. Solid is the type of line, and it should be black. Now the border radius is gonna be 50%, meaning that we are going to have a circle. Let's display as a flex, and as usual, align the items to the center, justify the content to the center. I'm gonna gonna give it width of 100%, meaning it's gonna take the shape of the one grid element, right? And the height is also 100%. Let's go. And as you see, here we go. This is our circle. This is kind of snake segment, right? Now, the second thing that we wanna design is the snake head. It's also a class. Let's go. For the head, we are going to use the asset that we got already. So background URL. So we are going to grab in the assets the snake head. Nice. The background size is gonna be 100% and 100% vertically and horizontally. Let's make the head a bit bigger, 1 times 1.5 by just giving it 150%, but also the height should be 150%. Now, since we gave it 150%, I want to be sure that it's also centered, so I'm gonna use object fit cover, but also display flex. Let's align the items to the center again, justify content to the center, and we need a bit of transform, and it's gonna be translate function, and I'm gonna go for 25% and also 25%. Let's save. Here we go. This is the head that we got. For now, it looks a bit messy, as you see, but before we are done, let's also add, for the sake of testing, let's also add our apple, right? So another div having the class apple. Let's grab this class and style it. And guess how I'm gonna do that? The same as before. Got the background, then I'm gonna use an URL method. In the assets, I'm gonna grab the apple.png, which I've already prepared, the red apple that we got. For sure, the background size is gonna be also 100% vertically and horizontally. I'm just making that so we can play with it in the future. I'm just preparing it. We don't need really an index because the position is already done perfectly. What we need is some width, 100%, and we need some height of 100%. Save and check. As you see, we got the snake head, the snake segment, and the apple. And with that, we already got these tiles done. So let's move to the real code and the JavaScript of the game. So for the sake of clarity, I'm gonna remove these now, just to be sure that the board is empty. These were just for the sake of seeing our styles. And let's get to the real code now. So first, I wanna work on the main section. So I'm gonna create a main function, right? I'm gonna have a parameter, which is current time. And actually what I'm gonna do is I'm gonna use the window. On the window object, there is a method which is called request animation frame. This method tells the browser basically that you wish to perform an animation, and you request that the browser calls a specific function, which is gonna be our main function here, right? So or we are going to call this main function, which is gonna be updating the animation before the next repainting, before we paint the snake, for example, or the apple. We'll come to that, but for sure we want to evoke the whole thing from outside too, not just from inside. Now, to have a better understanding, I'm gonna create a variable, right? I'm gonna call it seconds since last render, right? And this is gonna be the current time, which we already passed in, minus the last render. All of these are gonna be divided by 1000, so we have them in seconds, because the current time is gonna be in milliseconds by default, right? Now we wanna define the last render. As you see here, we got this variable called last render. Let's use camel case. Let last render, I'm gonna assign it to 0. And what we wanna do, every single time when we finish this whole loop, or when we finish our animation frame, we wanna set the last render to the current time, right? This is the last thing we wanna do, and then we get out of the function basically. Let's log it to the console so you have a better understanding what I'm doing. Seconds, last render, check it. As you see, these are the numbers, right? 0.003, as you see, these are the numbers. Now, if I just remove this 1000, you will see that these numbers are gonna be like 33, right? These are in milliseconds, but we wanna keep them in seconds. And if you just remove this one, it will keep increasing, as you see, increasing till the end. Okay, that's why every single time we wanna reset it, right? And now what we are getting is 0.03, 0.03, and so on, right? So here's what we wanna do now. We wanna write an if the seconds since the last render is smaller than 1 over the snake speed, then we want to return, meaning we want to do nothing, right? And this snake speed, I'm gonna define it here as a global variable again and assign it to 2 for now. Let's save. And as you see now, what's happening is we are rendering the frame and requesting the animation frame 2 times per second. You see, that's exactly what we need. That means this is the speed of the snake, which is gonna be moving. We'll get to that later. Just for the sake of readability, I'm gonna add some comments. This is the main, these are the variables, right? These are the variables. So now at the end of every single animation frame, we wanna be sure that we are calling a function which is gonna draw everything for us, like the apple, the snake, and everything, right? And I'm gonna call it directly here, draw, right? But we wanna be sure for sure that we are defining this function. That's why let's create it. It's the draw function. And as I've said, this is gonna draw different things. That's why for the sake of clean code, let's just go to call the draw snake function from inside here, right? And then grab this one and define it on its own function, draw snake. So if we think about it for a second, how are we going to draw our snake? So this is the snake code. The snake is nothing but different grid elements after each other, which are given the class snake segment, which is gonna make it green. So if you think about that, first we need some kind of placeholder, because this is gonna have an X and Y. X is the row position and Y is the column position, right? So I'm gonna create snake body, and it's gonna be an array of what? Of different objects. So the object would be something like X is equal to 8, Y is equal to 8. This means it's in the middle, because we know that we got 16 rows and 16 columns. It means 8 is exactly in the middle, assuming that we are starting from indexing from 1. And then let's just go for X7, but also X6. Now we want to draw this snake body. To draw the snake body, for sure we want to loop into this array. So I'm gonna grab the array, use for each to loop into it, and we want to do something when looping. And for sure we want to grab each one of these, which is gonna be actually a snake segment. So I'm gonna give it the name of snake segment. Right now, if we think about it, what we want to do, we want to create a new element. So constant snake element is going to be equal document object dot create element, and the type of the element is div. So we got a div HTML element. Right now, this element should be given some styles, so we want to see it. That's why I'm gonna add into the styles. Actually, I'm into the class list. I'm gonna add a new class which is called snake segment. Why snake segment? Because we've already prepared this class here, snake segment. Circular, basically a green circle, right? But also want to give it the position on the grid. For that, I'm gonna grab first the game board, which is the whole grid. So game board gonna be equal document dot get element by ID, and the ID of the game board is game dash board. So what we want to do, we want to grab the game board, right, and append this whole child, which is the snake element, into it. But before we do that, because we didn't give the snake element an actual position on this game board, that's why we want to give it an actual position, and we do that by having the snake element dot style, and on the style give grid row start gonna be equal to what? To the snake segment dot, which snake segment is basically one of these objects, right? The one where our cursor is actually currently is, assuming 7 8. We want to grab the Y and set it for the row, but also we want to grab the X, and instead of row we'll go for the column. So now we have the row and the column of the snake element set, and we appended the whole thing in the game board. Let's just be sure that our function is called in the animation frame in the main function, which is the draw, and the draw is calling the draw snake, which is gonna actually append the snake. Now let's refresh, check our code. Here we go. See, this is our snake. And now you are asking me, but Jad, where's the snake head, my bro? It doesn't look really good. I got you, my brother. I got you. To do that, I want to grab the index also, right, in the parameter of the for each function. This is the callback function, right? So we pass the index parameter inside, and what we want to do is actually to check the index. So if the index is gonna be equal to 0, meaning it's the first array, then we are going to add another class, which is in our case snake head, right? Else we add the snake segment. Save, check. Okay, I just forgot add method here. Let's go. See, we got our snake head. Okay, it looks weird, right? We'll fix it. Let me just stop these seconds because we don't need that for testing anymore. I'm gonna comment it out, and much better would be actually to remove it. So now let's make this snake move regardless from this very weird head. We'll fix it later. Let's make it move. To make it move, I'm gonna create a new function which is gonna be update, and as usual this update function is gonna be called here outside, so update, and I'm gonna grab this update snake and define it under draw snake. So function update snake. So actually what we wanna do, wanna always on every single new frame, right, we wanna add the x's, right, the x. Let's just add the x for now so it moves horizontally like this, right? To do that we could grab snake body 0.x, so we change the snake body, which is also actually being drawn in every single frame. So we want to update it. How to update it? We can just for now add something like 1 for now, so it moves 1 1, right? And the same for the y. Let's save and check what's happening. Update is not defined. Yeah, for sure it's not defined because I've written that wrong. Let's go now, and for sure the update snake should be also. Let's go. As you see now, what's happening is the head is moving down, right? What's happening is it's moving in a kind of diagonal. Why? Because I'm adding both of these. Let me just add this one, it will move horizontally. If I just add this one, like 1 0, it will move horizontally. Now if I reverse it, it would be moving vertically. The first thing that we want to do is, as you see here, this repetition is happening because we are not cleaning the game board in every single frame. We want to clean it. How are we going to clean it? In the draw function, we grab the game board and the inner HTML of it should be empty. Save, check. Now only the head is moving. Why is this actually happening? Because I've applied it directly just to the head, but we got the whole snake body. That's why we want to loop into the whole thing and let it move together. Now there is something that we need to be careful about, because we don't want to grab this whole thing right, and move together like as a whole piece. What we want to do is we want the snake to move like this, right? That means if the head has moved down and then here, the next segment will be following the head, right? So we'll be always actually, each one of these circles will be following the next one. And doing that is not actually that hard. All we need to do is to loop using for, right? So let I start from the snake body dot length -2, because this is gonna be the first position. Then what we wanna do is we wanna be sure that it's bigger than 0. When it's bigger than 0, we wanna keep decrementing. This is the for loop. And what we actually wanna do is we wanna grab the snake body I +1, meaning the last element, because we are starting with snake body dot length -2, which is the second last segment of the snake. So +1, that means the last segment of the snake. So the last segment of the snake should be actually destructured and snake body equal to I. We are moving it to the next one. You see, the I is actually the second last segment. This is what we actually want to do. Now let's just be sure to save, and we got a semicolon instead of comma here in the for condition. Save and check. You see, it's exactly moving as we want it to move. That's nice and smooth. Now since it's moving, but it's moving down, right? And the head is looking a bit weird. We'll fix that in a second. But what we want to do is let's give it some direction. So I want to control it, right? Control it with the keys. To control it with the keys, I'm gonna add another new variable. It's gonna be last input direction. This is gonna be the input direction. I'm gonna start with x0 and y is 0. This is actually the amount that we want to increment here. That's basically what we are doing, right? Now what we want to do, we want to listen on the whole thing. So I'm gonna listen here. Let me just grab a new command, input direction code. So on the window, we add an event listener, and it's gonna be key down, meaning listen to the keys, the 4 keys on the keyboard, which are up, down, left, right. Wanna fire an event on the callback. We wanna do a switch statement. So wanna check the E key, and then we have in the case of arrow up. So when we click on the arrow up, wanna set the input direction, which we didn't really define. So let's define it very quickly. It's gonna be the same as this one, right? Just instead of last input direction, it's gonna be our input direction instead. So our input direction is gonna be, in our case, x is gonna stay 0 and the y is gonna be -1. Okay, nice. This is the first case. We still have 4 cases, so I'm gonna duplicate it. So we got arrow down, then we got y is equal to 1 instead of -1, but I'll also arrow left, meaning x is -1, the y is gonna be 0. Let's copy this one, paste, and then here 1 instead of 1 when it's arrow right. Save, remove the default, we don't really need it. Now till now what's happening is we're changing the input direction whenever we click on the keys. This is changing. Okay, this change that's happening should be actually added to the snake body, to the first one. So actually we change the direction of it, right? So just instead of this 0, what we do is the input direction dot x, and instead of 1 dot y. So now this 0 and 1, right, or -1 or 0, these are gonna be dedicated by our key clicks. Save, let's check. Now nothing is happening, as you see. We click key down, it goes down. Click key right, it's going right. Click up, goes up. Click left, goes left. Let me fix the head, and then we'll get deeper into it. So to flip the head, I'm gonna create a new function, call it basically flip head. So function flip head, and we wanna pass in the snake head, right? How to determine how to flip our head? It's related to the input direction. So if the input direction is down, the head should be in a particular way. If it's right, particular way. If it's up, the same. And if it's left, also the same, right? To do that, actually, we want different if clauses, right? So if what? We want to check the last input direction, if the x of it. So we have 4 cases basically. First case, if the input direction dot x is 0 and the y is 1. What are we going to do in this case? We'll grab the snake head, which we've passed in. Want to be sure that it's passed in the right way. Grab the style, use the transform. Then what we could use is the rotate function in CSS. In our first case, we want to really do nothing. That's why 0 degrees. Now you can think how it continues. You kind of just paste the whole thing. So if the y is -1, we rotate 180. If the x is -1, we rotate 90 degrees, and so on. I'll explain this translation in a second. Let's save and check what's really happening. Now as you see, as I go right, it's not flipping yet because I didn't call the function, right? So let's grab the function. Think about it. Where do we want to really flip it? We want to flip it in the update snake. And when exactly? We want to flip it in the draw snake, right? And when exactly? Exactly when we add the head. So we want to call the function flip head and pass in the snake element. When? If the index is equal to 0. Our only problem still that the last input direction is not updated yet. So it's always 0, 0. That's why, as you see here, nothing is flipping because the last input direction is not really changing. And the whole flip head is related to the last input direction. That's why I want to be sure that it's updated. For that, I'm going to create a function. It's going to be really an easy function. All we need to do is get input direction, and all we need to do is to set the last input direction to what? To the input direction. Nice. Then we return this input direction that we got. We created the function, we still need to call it, right? To evoke it. Exactly where we are setting the input direction, which is in the update snake. As you see here, we are using the input direction. So before we actually use the input direction, let's just use it by evoking the get input direction. So basically it's the same, but instead of grabbing the value from here directly and using it, what we are doing is inside this input direction, we are calling the get input direction, which is this function. And if we take a look about it, it's still returning the input direction from here. But before doing that, every single time before doing that, it's saving the input direction in the last input direction, right? This last input direction is used inside of the flip head. And now if we save, we'll see that our snake is working. Nice. And even the head is actually exactly in the center. You see, man, you just click key down, it moves. Key left, it moves. But the problem is, if I click now, key left, it's kind of going against itself. Let's try it up and down. The same, if it's going up, I click down, it's going down. And that's not allowed. We don't want to allow this. We want to prevent going in the same direction. Like if it's going left to go right spontaneously, and if it's going up to go down. We want to prevent these because it's just much better, right? Makes sense. So to do this, think about for a second, what are we going to do? Write in the comment. So here we go. All we need to do is always when we are going, all we want to do is to check if we are clicking on arrow up, but we know that the last input direction .y is not equal to 0, then we're going to break, right? We're creating this break. That means if it's already going vertically, we don't allow it to go up, right? The same on the arrow down. If it's already going vertically, then we don't need this logic. That means arrow down and arrow up don't really matter if we are already going vertical. That means like if you click up and you are going already up, we don't want to do nothing. But the same if we are going down and we are clicking down or up, we don't want to allow it. That's why we are breaking. But the same is gonna be for the arrow left and right. Just instead of the Y, we're going to write X. Let's go. And this is how you create this kind of break. Now let's go right. Nice. I'm trying to go left, can't. I go up, I can. I go down, it's not allowed. That's what we need. It makes more sense now. So let's create our apple. Let's create our apple somewhere. To create the apple, we wanna first create a new code section, just like to keep everything clean. I'm gonna call it apple code, right? So inside the apple code, we are going to have function, which is gonna be draw apple, right? The same as the snake. If we check the draw snake code, you see that we are creating an element, adding some styles into it, and then positioning it, right? The same is gonna happen for the apple. Just we don't need to loop because it needs just one single position. So let's go create the apple element using document.create element and its div, right? Apple element.style.grid row start. It's gonna be equal to apple position.y, and I'm gonna define the apple position as a variable. The same for the column, grid column start, apple position.x. And now for sure we wanna add some styles. To do that, class list.add. Then we add the apple class that we've already styled. Last but not least, we grab the grain board and we append this whole apple element inside it. For sure, as I've said, we wanna define this apple position. Let's go to the variables. Makes sense to define it under the snake body. So let's go for let apple position, and I'm gonna go for x is equal to 4 and y is equal to 4 for now. Save, check. But for sure, before doing this whole thing, we wanna be sure that we are calling this function on the update, right? On the draw function. So here's our draw apple. We wanna evoke it from the main draw function. Let's go. Now we save, we check. As you see, this is our apple, nice and clean. The thing is, first the apple is taking a particular position, right? So we want to change this position. Every single time we refresh now, it's fixed on this position 4. So I wanna give it a random position. And for that, I'm gonna create a new function and call it get random apple position. Let's go. So what we wanna do is let new apple position. This is a variable that we are going to use in a while loop. So when the new apple position is actually null, we wanna keep looping and actually giving a new apple position. This new apple position is gonna be generated randomly. That's why I'm gonna use another help function that I'm gonna define in a second, which is gonna be called generate random grid position. Let's go. Last but not least, we wanna be sure that we are returning the new apple position. Let's now find the second function, which is generate random grid position. And this should be actually really easy. If you are familiar with math random library in JavaScript, this should be really easy. We wanna return an object which has an x and y, and this x and y are gonna be randomly chosen. That's why I'm gonna go for math, but for sure we wanna approximate the whole thing, right? Math.random, and the random gives us, as you can see here, numbers between 0 and 1. When using the floor function, we are being sure that we are just choosing integers, right? We're not taking the decimal numbers. We don't really have a grid position with decimal number, like place the apple on 2.5. We don't have something like that. We just have have like 2, 3, 4, and so on. And it doesn't make sense to just grab a number between 0 and 1 because it's gonna be always 0 or 1, right? So we want to multiply this number, which is between 0 and 1, with what? With the grid size. We know already that the grid size is 16, but a good practice is actually to, let's go for grid size plus 1, because we don't want to choose the 0. The grid system starts from 1, so the first index is 1 and not 0. That's why I'm adding 1 here. And we want to define this grid size. The same thing we are going to do for the y, but as I've said, we want to define the grid size. We know already that the grid size in our case is 16, but in case we change it, let's just define it globally, right? Let grid size is equal to 16. That's it. Save, right and comma after the x. And now what we are really doing, let me show you what we are really doing. This function gives us a random position. This random position is always given to the new apple position whenever the new apple position is null, meaning we are always checking if the new apple position is null, then we are giving it a new generated random position in the grid. And this whole function, how is it working? How is it always checking the whole thing? We are calling it where, think about it for a second, we want to call it here instead of this hard-coded apple position. So get random apple position. Now what we are doing, when the application starts, we are setting this apple position to a new random apple position, right? Let's save, check it. Now whenever you refresh, another random position is taken. Nice. But think about it for a second. Actually, the logic says like, first, we don't want to generate the apple on the snake. That's one. So we want to be sure when we are generating this apple that it's not on the snake. How do we do that? We just be sure that the positions are not equal. But second, when the snake and the apple are having the same position, let me try to eat it. Man, it's so hard. Okay, for example, now what we want to have is for the apple to be regenerated because it's eaten. So these are two things that are related to generating the apple, right? And this is gonna be actually the update apple function that we want to create here. Let's go for it. So we got our function called update apple. So what we want to have is if the position is the same, we want to do something, and this something is gonna be that the apple position should be regenerated, right? Now while regenerating here, actually we want to always not check just if it's null. If it's null or if it is equal to the position of the snake, meaning we got some or here is equal to the position of the snake, then we want also to keep regenerating till we find a position which is not equal to the snake position. That's why I'm gonna evoke a function which is gonna be defined in a second, and this function is, I'm gonna call it is on snake, right? This same function, and what I'm gonna do is I'm gonna pass in the new apple position. Now this on snake is the same function that we wanna really check here. I wanna check if it's returning true or false. Is then we got apple position. So if the apple position is on the snake, so if this is true, right, we'd regenerate the apple position. While regenerating the apple position, we want to always be sure that the new generated apple position is also not equal to what, to the snake, because if it is, then we will generate the apple on the head of the snake or like on the body of the snake, which shouldn't make sense, right? Now let's write the logic of this is on snake function. So it's related to the snake, that's why I'm gonna write it here. Function is on snake. So got the apple position here, and what we want to do, we want to return snake body dot sum. So the sum applies a particular function on all the elements in this array. So the function that we want to apply is the following. We've got a snake segment, right? We want to do something with this snake segment. This is the function which we want to apply to every single element in this snake body, right? So for every single snake segment, we want to return if the snake segment dot x is equal to apple position dot x and the snake segment dot y is equal to apple position dot y. Meaning if the snake segment, the x and the y, that means if the segment of the snake, right, is equal to the position of the apple, the new position, then we want to return what? True. That means it is on snake. This function here will be applied to all of these snake body elements, meaning the snake segments. Meaning at the end of the day, we get true or false, meaning we're going to check if the apple position and any position of any segment of the snake is equal to each other or not. So for sure, we want to be sure now that the update snake function is also called from the update function, actually in the right way. I want to call the update apple, not update snake. So now let's try to just hit the apple with the snake and see what happens if the positions are equal. Okay, we got an error here that get random apple is not defined. So let me check. Why is it actually not defined? So obviously I've misspelled the position. So let me correct it even here. And for sure here too. I want to correct it, position. Okay, so obviously I've written the apple position also wrong. So apple position. Some spelling mistakes sometimes just mess everything, right? So let's be sure that we are correcting it. Position. Let's save, check now. Let's go eat the apple. So now as you see, it's working. It is working. See, I'm eating the apple and it disappears. So let's write the logic. When the snake eats the apple, it should grow. Now, first, let's just start with one single head when we are starting, because it doesn't make sense that we are starting actually with 3 balls, right? So let's start with just one. All we need to do is just to remove these both. Save. Now we got just the head. Let's try to eat the apple. Okay, we want to grow the snake when eating the apple. That's the goal. How to do that? I'm gonna create first a variable, and I'm gonna call this variable new segments. Gonna initialize it, and we want to actually create a function in the snake code. Let's go. This function is gonna be add snake segment, right? Segments. The add snake segments, we are basically gonna loop into the whole snake. So I'm gonna remove this line. What we wanna do, we wanna loop into the snake body, start from the first element, loop onto every single segment in the snake. And then what we wanna do is segment body dot push. So we wanna push a new object. Let's be sure that we are destructing it. Snake body dot length -1, right? So we are pushing a new snake segment into the end of the snake body. This is what the function do. And for sure, we want always to set the new segments to 0 after we finish. Now we want also another function which is kind of incrementing the new segments that we want to add. So the new segments is the variable where we are saving how much segments do we want to really add, right? Function, I'm gonna call it expand snake. This function is gonna basically just do one thing, which is increment the new segments. So now let's ask a good question, where to trigger this expanding snake. This should happen always, right? So we are always at the snake segments. Let's check. So that means under the update snake, we are going always to call this function, which is gonna update actually the body of the snake. Okay, the question is, somewhere we should trigger the another function, which is expand snake. So I mean this function here should be triggered also somewhere, right? So in every frame we are calling this function, which is also depending on the new segments number. So if the new segments number is 0, we are adding nothing actually. So this is always gonna be called. Depending on the new segments number, it's gonna add some segments to the end of the snake body. But we wanna trigger this one. So the question, where to trigger it? Think about it for a second. When we eat the apple. When are we eating the apple? What does it mean to eat the apple in this code? It's basically in the update apple function, exactly here. So we're updating the apple, right? Whenever we are updating the apple and we want that inside of this true is on snake. So if the apple is on snake, we are changing the apple position, but we need to also expand the snake, right? The expanding the snake means increasing these new segments. But for sure, we want to be sure here that in the snake code, in the add snake segment, I've just made a mistake here, because what we want to do is we want to start from 0 and end into the new segments. That means if the new segments is 1 because it's triggered because we ate an apple, what happens is we loop into it and we add it to the snake body, right? Now in the most of the cases, what we are doing here is we are just incrementing 1. So that means this doesn't really make sense, right? No, that's wrong, because with time we want to expand the algorithm of the whole game, and maybe what we want to do is to basically with time, like so the first time you eat apple, you increment just 1. The second time you increment 2. Third time you increment 3. But this is a feature that open and we can build it together later. Let's refresh and see if it's really growing when we are eating the apple. Nice. So whenever we are eating the apple, we are growing 1 extra segment of the snake. Now the last thing that we really want to build is the death of the snake, because now I'm just eating apples and getting bigger, but it doesn't really make sense. We need to die somewhere. And the question is when to die. First, when I just hit the wall, I need to die, right? What's happening now is just like doing some random things, right? We want to die when we hit the wall. So in order to make that, I'm gonna create a function and call it actually on the update main function. I'm gonna call it check death. So the check death function is gonna be basically that the game over, which is a variable that I'm gonna define. Let me define it very quickly. So let game over is equal to false first. Game over means game is ended. You lost. So game over is gonna be dedicated by what? It's gonna be dedicated if the snake is outside the grid. And this outside the grid is not magic. We need to define it too. So to define it, I'm gonna again duplicate this code. Let me write here grid code, right? And I want to define this function. So function is outside grid. Actually, all we need to do is return if the snake head is less than 1, or it's more than the grid size, or the y of it is less than 1, or bigger than the grid size, meaning it's out of these. So if the y is less than 1, meaning anywhere here, right? Or the x is less than 1, anywhere here. Or the y is anything more than the grid size, but also if the x is anywhere bigger than the grid size, then we want the whole snake to die. But how to dedicate that? We want to focus on the the head, right? Meaning snake body, and we want the first element, which is the head, shouldn't have an x less than 1, or the snake body having an x more than the grid size, or what? Same thing for the y. I'm gonna copy, paste. So if the y is less than 1, same thing here. If the y is bigger than the grid size, right? So if any one of these is true, this means that the snake is out of the grid. So we wanna trigger something on the screen when the depth is true. How are we going to do that? In every single new frame. So always when we are starting this main function, right? Wanna always check if game over. What do we wanna do if game over? Then we can send an alert using the confirm. Let's say game over, click OK to restart. And sure, we want to do something if this happens. And what we want to do is let's just change the location to the same one. So that means just refreshing actually. So if the game over, we pop up this box where you need to click on OK. Then if we click on OK, it refreshes and we start the game. Let's go. Let me try it straightforward to go through the wall, see what happens. You see, game over, click OK to start. And then when you click OK, as you see, something weird is still happening. Why? Because the restart is not happening in a good way. We are not refreshing the snake head again. So we need to be sure that we are doing that, right? So to do that, we can just return. Let's go, click OK. So let me now try to go and hit the wall. I'm clicking OK, it refreshes. Nice and clean. Now the score should be incremented when eating the apple. For that, I'm gonna create a new variable. I'm gonna call it score. It's gonna be equal first to 0. And then I'm gonna grab actually the box where the score is saved, right? To do that, I'm gonna call it actually score box, right? All we need to do to document.getElement by ID, and it's called score, right? Save. And all we need actually are two very simple functions for that. So this is gonna be the code for the score box code. Nice. So we need a function called update score, and all we need to do is actually to update the score directly into the HTML using the inner text is equal to what? Is equal to the score, which is this variable that we are always updating, right? What does it mean to always like update the whole thing? What does it mean? Actually, it makes more sense to use here something like draw score, right? And then we need another one, which is gonna be function update score. This update score is gonna be actually just this one single line, which means I'm gonna for now add just 10, right? With time, you can even make it gamify it more, and maybe you can use Fibonacci sequence multiplied by 10. That means like, okay, the first time you eat the apple, you add 10, and then you add 10, and then you add 20, so on, right? You can make like gamify it a bit so it's not that easy and linear, and you can change the apples, and each kind of apple gives you a different score, right? And now we just still need one thing. When eating the apple, we want to be sure that we are changing the score. So let's go to the apple code. When updating the apple, especially after eating the apple, right? We want to first update the score, and for sure we want to also draw the score. Let's go. Let's save. Let me eat the apple. To make it a bit easier, I'm gonna add the speed of the snake a bit. That helps. Now the snake is a bit quicker. Nice. One last thing that we want to do is, what if the snake is getting bigger and we just go through ourselves? Meaning, let me eat that apple up there. Meaning, what if we just do this, right? So we are moving on ourselves. We wanna also die. To check this whole thing, let's create in the section of the snake code another function that I'm gonna call function is snake intersecting. Think about it. What we want to do is we want to just check if the snake is on the snake, if the head of the snake is on any segment of the snake, right? And we already have a function which we are using for the apple, which is basically checking if the apple is on the position of the snake. So what we could do, we could modify this function. So when we pass in, for example, something like the head is true, then we use it for this method as a help function. And for the apple, we just keep it false as standard. Okay, maybe you don't understood what I'm meaning, but I'm talking about something like that. To use the function which is already there instead of creating a new one. So we got is on snake, our function, and in this one we always pass in a segment, or we pass actually like something that we want to check if it's on the snake. So now what I'm doing really is checking if the first segment of the snake is on the snake, right? Let's save. Let me check actually this function which is on the snake. And here's the thing, if we are checking if the head of the snake is on the snake, it will always give us true, because the head of the snake is already a part of the snake, so it's already on it, right? That's why what we want to do, we want to modify this function a bit and pass in another parameter, right? This parameter, I'm gonna call it ignore head. I'm gonna set it for false for now, and for sure it's gonna be equal to an empty object. That means we can pass in an object, and what we wanna really do inside is wanna check the ignore head, which is this key in the object here. If it's true and the index is equal to 0, we return. So we are skipping actually if we are setting the ignore head to true. So if the ignore head is true, we are just like skipping the comparison of the snake head with the snake head, right? right? So that means all we need to do is when calling isOnSnake function down here in the isSnake intersecting, we want to be sure that we are setting ignore head to what? To true. This means it will not particularly give us true just for the sake that the head of the snake is on the head of the snake. It will skip this case and compare if like the head of the snake is touching any other segment of the snake. That's what we want to really do. Let's save. Be sure that when the snake is intersecting, then we need to set the game over to true also. So to do that, I'm just gonna write or. So game over, when we are changing the game over, is if we are outside the grid or if the snake is intersecting. So I'm gonna add this one here. So if the snake is intersecting, the game over is true. And by default, if the game over is true, we are going to send this message. Let's check now. Okay, as you see, snake body is not a function. I've done something wrong. Let me check it very quickly. Yeah, I think this one here. Yeah, it's not a function. I used the wrong braces. So actually what we want to do is we want to use these instead. Let's save. Let's check. Index is not defined. Well, yeah, we didn't define the index, which is isOnSnake here, right? We want to be sure that with the passing, we are passing in even the index. So the sum or the for each, right? You can always pass in not just like the element that you want to work with, but you can also pass the index, the current index that you are in while looping, right? That means in the first loop, the index will be 0. And this one will be skipped if the ignore head is true. Now let's now save. We just forgot that. Now we got no errors. Let's eat the apple, right? We eat the apple a couple of times. We make the snake big enough so it could hit itself. We need to be very careful. It's a hard game. Oh yeah, let me grow a bit more so hitting myself would be easier. Oh shit. Okay, so let's hit ourselves. Yeah, let me just do it in the middle so we don't hit the wall. Okay, actually we've already hit ourselves. Okay, I know the problem. The problem is that we're not actually checking this is intersection. We need to check it when the return falls here, right? Or maybe the problem is just because we didn't return this whole thing. I'm not sure if it makes sense we are returning 2 times. Let me return it, see what happens. Okay, we need to refresh obviously. Let's go now. Game over, click. Okay, to restart. Okay, nice. So let me just remove these, all of these. Maybe like this. Let's save. Okay, so let's eat some apples. Grow the snake a bit. 1, 2, 3. Shit. 2, go snake. Go green snake. Yes. It's hard to loop, man. Okay, let me eat one more apple. Nice. Game over. We've done it. We have done it. We have done it. Let's go.